Hi, my name is Surman from Agent Technologies. Today I'd like to introduce you how to evaluate a low noise amplifier LNA. Right here I have a network analyzer for the RF measurement. I also have a power source B2960 for biasing the amplifier. The LNA I will use here is the monolithic amplifier GALI21 from Mini Circuits. Let me explain the connections. The amplifier has three ports: RF in port, RF out and DC in port, and ground port. First, I connect the power source to the RF out and DC port. As I only want to supply a DC bias to the amplifier, I insert an RF choke here to block AC signals. Then, I connect the network analyzer to the amplifier's input and output port through DC block capacitors. For biasing the amplifier, this time I will use a voltage source and a bias resistor. According to the datasheet, the recommended bias current value is 40 milliamps and the typical device voltage is 3.5 volt. I'm going to use a 10 volt voltage source, so the bias resistor value is around 160 ohms. Of course, you may use different combinations of bias voltage and resistor values, but be cautious that the device voltage changes, for example, due to temperature drift. So, higher bias voltage and resistor values reduce the variation in the bias current. Now, let me demonstrate the Sparameter measurements of the LNA. I have already calibrated this network analyzer and made all the connections ready. So first, I will set the power source. Set the output voltage to 10 volts and then set the current limit to 50 milliamps and press the output button. You can see the current flowing is about 40 milliamps. The device is ready, so let's start the measurement. Press the trigger button and start. So these are the Sparameter measurement results from 10 MHz to 20 GHz. Today I showed you a brief introduction on how to evaluate an LNA. In the next video, I would like to focus more on the external biasing of the amplifier. If you like to have more information, you can visit our website currently shown below. Thank you for watching this video.